It is. It is coming soon. Right. So, as Andy has just pointed out to me, this domain here says coming soon. That's because I don't have enough bandwidth to upload the screencast of this that I recorded. But let's assume that what I will do sometime before Monday. So if you guys want to check back then, when I have a venue which has bandwidth. All right, we might as well get going. Hope everyone had a good lunch. This is Exceptional Exceptions. And who am I? Well, I'm Mark Fowler. I'm not that fictional guy. I'm not the serial killer. Not a kickboxer, nor a university lecturer. I'm just another Perl hacker. I'm the ex-lead of London PM. As you can tell, I've got the funny accent. I created the Perl Advent Calendar, and I've spoken at... Thank you. I've spoken at Perl conferences for over 10 years, and at the moment, I'm employed by OmniTI, who you may remember from Brains in Your Bags, the Surge Conference, Omnios, or Seconus, the monitoring solution, and we're hiring. Right, advert over. Back in Vienna in 2007, I gave this talk about how Perl sucks, and of course what to do about it. And some people listened to me. One of the things I said was, I really want to kill Perl's exception handling. Back in 2007, Perl had terrible exception handling. But now it's 2012, and things are a lot better, so I'm here to tell you, everyone, it's great, and you should all use the new stuff. But before we get to that, let's go back in time. Let's go back to the good old days of dinosaurs and the beginnings of Perl. When people thought they had an idea of how to handle problems in their code, they would return undef, or return 0, or return an empty list, or return false. And this got enshrined in a lot of things, like opening files returns false when it fails. Making a directory returns false when it fails. Change dir returns false when it fails. In fact, printing returns false when it fails. And it got taken into third-party modules. So the DBI, for example, returns false if it can't process the SQL. And template toolkit returns false if there's a problem with your template. This sucks. Let me list the ways. It is tedious. Okay, there's a problem with my file handle. I need to check that the open works. Not too bad. Let's make a directory and put a file in it. Oh, there's a few ones there. Yes. That gets old real quick. They're not particularly informative. There's a problem. Yeah. The problem. A problem. A problem? What problem? What problem? Okay, so you need to go look in $pling in this example here, or $bang, depending if you're a mathematician or a linguist. And then you can find the problem with file handles. And if you're using the DBI, you need to go look in Erstra. Easy to pronounce that one. Or in Template Toolkit, you need to look in error. So there's all these out-of-band details, and you have to know where they are. And if you want to pass that around, you have to gather them all up and pass them around. And believe it or not, writing modules which do this is also complicated. So third, I couldn't think of a good word for this, rageful. You think this is tedious. Okay, let's write a parser. We're going to process a file, and that's going to call parse header, and that's going to call parse line, and that's going to call parse statement, and that's going to call parse function, and that's going to have a problem. Now, if these things are returning undef or something, we have to return undef, then check whether it was there, return undef, check what happened, return what you really want to do is that. You want to jump right back up to the processing file and say, this file is no good. But you can't do that with just returning undef. So in summary, tedious, uninformative, rageful, annoying. So let's talk about exceptions, which luckily is what I'm here to talk about. Who could we ask how to solve this? How about Vanilla Ice? Who said, if there's a problem, yo, I'll solve it. So he sounds like he knows what he's talking about. He also said, stop, collaborate, and listen, which is actually what exception handling is about. You stop doing what you're doing, and you collaborate with some code that you've previously registered that's listening for errors. It's the throw and catch methodology.
You throw the error, and you have a catcher's mitt of code which catches it. Now let's talk about a wonderful programming language, Java, which actually does have a really nice exception handling syntax. So we have these try and catch blocks here, and everything within the in the try block is a kind of area where exceptions can be thrown, and then the catch block below handles it. So let's throw an exception. This is how you do it in Java. I say throw a new exception, a problem, and then we jump immediately to this error handling here, which it just prints out there was an error. But it jumps. This code here is never executed. And of course, I don't just have to say throw in this. It's any code that is called from within this try block can throw an exception which will be caught by this try block. So this is possible. The parse functions throws the exception and process file catches it. It's also worth noting for a language with really nice throw semantics, they don't know how to spell print. But let's look at something else. Let's look at Perl. So what do you think happens in Perl? Oh, yeah, there's more than one way to do it. In fact, there's lots of ways to do it. Let's talk about the top 3 ways to do it. There's eval, try tiny, and catch. So eval. Eval doesn't actually have a try. It has things which map to other things. Let's just show you an example. It's easier. So eval and then an if. So this eval is our try block. This is where exceptions can happen, and they will be caught. But we don't have a catch block. What we have is a $@. So if an exception is caught, it's shoved in $@. And if there was no exception, the eval clears the exception, sticking undef in $@. And you can inspect that however you want. If is good enough for here, but we'll get on to more advanced ways. And then we have die, which is how you throw an exception. So this is all ugly reuse syntax, which sucks. Eval is really often confused with eval string, which is how you compile Perl code within Perl code, not how you have it doesn't act as a try block. And, you have this die statement, which means terminate the program with this error message to everybody, not throw an exception that will be caught. And then you have this semicolon, which you will forget. Because eval statement is not a block, it's a statement, which is a fancy way of saying you need a semicolon after it. So let's look at some of the alternatives. Try tiny. Fairly modern module with much, much better syntax. The try block is called try. The catch block is called catch. Though you still have the semicolon. The error, instead of being shoved in $@, is simply shoved in $_. So it's a simple extension to the syntax, using $ instead of _@. The key thing to know about try-tiny is it's a very tiny module. It has no non-core dependencies, and it's pure Perl, and doesn't use any tricks to do what it does. Well, it does use a few tricks. Let's look under the hood briefly. That is really that. So what you're actually doing is using clever prototypes on your functions to pass in subroutine references. Why that's important will become clear later. But anyway, let's talk about something a bit more clever than try-tiny. Let's talk about try-catch. Try-catch looks pretty much the same, to be honest, at this level. Try and catch are called try and catch. And there's no semicolon. Hooray. And we have named exception variables. But essentially, it's the same thing. Try-catch is actually introducing new syntax into the language. Try-tiny is just wrapping up subroutines and getting away with it. Try-catch is putting whole selections of new functionality in there. But to do that, it drags in incredibly number of dependencies, not to mention moose and devel declare, which will manipulate your source code. In fact, if we look under the hood, it uses devel declare to implement custom extensions to the Perl compiler to add new syntax, which is a scary way of saying it does scary things. But it's fast.
is much, much faster than try tiny because it doesn't have those subroutine overheads. It produces bytecode which looks pretty much like an eval code, generates bytecode. Let's look at some benchmarks. So eval's pretty fast. Try tiny is about 25 times slower than eval, and try catch is about a quarter slower. So try catch isn't that much slower than eval, considering the extra functionality it gives you, which I'll get to, well, now. Let's talk about rethrowing errors. So, we've had enough Star Trek references right now. Let's do a Star Wars one. We're going to get the Millennium Falcon up to light speed, so we call jump to light speed. And if there's a problem, that's going to throw an exception saying, I don't know, the faster than light drive isn't working. And if it doesn't work, we're going to get Chewie to fix it. So we're expecting something like can't jump to light speed at line, whatever. But we're not just catching that. We're also catching all other exceptions, like can't call method jump to light speed on an undefined value at, like, oh, we forgot to define the Millennium Falcon. And we don't want to get Chewie to fix it because he'll just go because he doesn't know where it is. So we only want to handle exceptions we want to handle, and all other exceptions need to be propagated somehow. You can do this with eval, where you just have difficult to read structures. I'm doing a simple check of this, and then if it's not working, I'm calling die with no arguments, which basically means just rethrow what the exception is. You can do the same with try tiny, same kind of thing, except I have this return here, because I'm returning out of that subroutine. So I'm saying I'm done, and if I get to the end, well, I just die. Try catch.
Can you not just fall out?
How would you fall out?
Well, instead, without that return, wouldn't that just fall out of the sub?
And then eat the error. It would then eat the exception.
Wait, can you go back one? Okay, that return there will fall out of the sub in the catch. Right?
Yes. And if I don't die at the end of this.
No. I mean, in the case of Chewie fixing the Falcon.
Oh.
Do you need that return?
Otherwise, I'm going to die, because I'm going to get to the end of the if.
Oh, never mind.
And I'll die. So the point is that the question was, can I not rearrange the structure somehow? And the answer is not really, because I need to die at the end of this if I haven't handled it. Try catch is much better. Try catch, I can have as many of these catch blocks as I want, and each catch block can decide whether it's going to fire or not. And if it doesn't fire, it will rethrow the error automatically. So in this case, I am examining. I'm saying this is E where $_, which is the exception, matches can't jump. So that's a lightning tour of the two modules and the internal syntax. Let's look at some of the reasons why you might want to use them beyond I prefer the new syntax. Destroy bug. Mothra. We all know what that is. I'm going to take a quick aside to explain what destroy is. So when an object is garbage collected, if a destroy method exists on it, it is called. Again, easier to show by example. They tend to be used for things like closing database handles, deleting lock files, writing contents out to a file. Anyway, doesn't really matter why. Let's just look at what happens. So there's nothing super magical. It's just called subdestroy, and so some class or other, when it is garbage collected, subdestroy will be called. So if we look at that running an example, we create it. We can print something else to show where we are. Then when we fall out of this type block here, the foo falls out of scope, is garbage collected, and our destroy routine is triggered, causing object destroy to be printed out, and then we can print out program done. So it's a kind of hidden statement you don't get to see. There's no code there, but it happens. And of course, Moose being Moose, it's not called destroy, it's called demolish, but let's not worry about that. It's just the same thing. What happens if we eval in the middle of that demolish block?
Well, okay, let's try it. We'll create some class or another. We'll die, which raises the exception. And then, of course, we jump out of the eval block because we're we're terminating. But at that point, we jump into the demolish block, run a different eval, which completes successfully, and then we go back to where this if is. Now, what does $@ contain now? Does it contain the error from the above eval, or the one in demolish, which didn't have an error? Well, the answer to that is, it depends. On 5.12.13, it contains the one in the demolish block. In 5.14, it does the more logical thing, and there's an error. It restores the $@ when it gets back out in the top. You can work around this kind of thing with eval. There are numerous techniques. The simplest is this. I'm making use of the fact that eval will return the last thing in it, which in this case will be 1. So eval, and always return 1 if I got to the end. But if I didn't get to the end, an exception happened, eval would return undef. So I would then trigger the do block. And I can guarantee the do block will be called. Of course, I don't know really what went wrong because $@ has disappeared on me. That's a really nasty way to do it. It's easier just to use try tiny or try catch, and they work. They use techniques to get around this, which you would never, ever write out by hand every time you were going to write an eval block. What else? Oh, the return problem. Okay, imagine that I have a cache, and in it I'm storing foo. And I call get foo. Oh, perfectly fine. But say I suddenly decide I want to populate the cache if it's not in there. And my cache will throw an exception to indicate I don't have foo. So I write this. Where does that return from? It returns from the eval statement. So this code here, it always gets run. So this just doesn't work. The return here can't get out of the subroutine. So, see, we can rewrap it like this, where my foo equals the return value from the eval and return foo if there is a foo, and lo and behold, if foo was 0, that's not going to work, but you get the gist of what is going on. Try tiny also doesn't work. These blocks here to try and these blocks to catch are subroutine calls. I'm returning from the subroutine I passed to try tiny. Yeah, you fix it the same way. Try catch. This works. Hooray! Because that's not really a block, it's some really complicated thing that you don't want to deparse. But anyway, it works. And you can return out, and this makes your code much easier to write, especially if you're like me and you tend to write lots and lots of small, tiny subroutines. It almost works everywhere. You'd expect here this last to exit from there. It doesn't. It exits halfway through the try block and gives you a nice error, but it almost works. Let's talk about something else. Enough about these 3 modules, 2 modules and core functionality. Carp. Nice picture. Carp is the core way of throwing exceptions from a different place, from further up the stack. So, package foo. When I call foo, I'm going to go into foo and die, and it's going to report an error happened in foo. If I change that to croak, it will tell me the line number for the error is at the point I called foo. This is typically the case you'd use this for. Say someone passed you a invalid input to your function. You might not want to. You probably don't want to report it in the middle of your function because no one cares.
but you want to probably report it from the point that someone passed you the invalid input. So in general, though the documentation is worth reading on this, the exception comes from the first subroutine outside the throwing package. You can also set up carp not. So here I've got 3 packages, main calling bar, bar calling foo, and obviously foo is still, just like in the previous example, is going to report the error from bar. Now maybe maybe bar's utility class that we wrote, and the error is still that they're not passing in the correct thing when they call bar. So we can use our carp not, which is a package level variable within bar, to say, I'm good with all errors from foo, just pass them up the stack. With this, you can manipulate where your errors appear to come from. So I've just talked about throwing essentially strings, which is all very well, but it's not exactly rocket science. There's a couple of problems with throwing strings. Firstly, imagine if I want to hand-act structured data in this. I'd have to extract it out of the string by using a regex, which is not a sensible thing to do, really. The other problem is that I would be relying on that string value being completely constant and not changing. Let's look at the first case first. Let's look at the case where I want to pass back some structured data. Let's create a package, give it a title, and some data. Naughty stuff. And then let's die with that instead. So I die with a new object. And then I can say, I can extract that information out from just the same way as usual. Not the best solution just yet. You see, when I die with a normal string, I die problem, and that falls all the way out through all my exception routines and gets printed out to standard error because no one caught it. I die with problem at line blah, 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 and I can read it. When I die with this, that gets printed to standard error, which is not the most informative thing. So, a quick digression into object overloading. Object overloading allows us to define what happens to objects when they're turned into strings or into numbers or evaluated in Boolean context or used with any of the operators like plus, underscores, dots, etc., etc., etc. Very quickly, there's this use overload module, which is a pragma, really. And I am saying, and I've got some stringification routine here. I want to return I want these to stringify to my foo, but assume I can calculate that there. I am saying that the quote that when I use this as a string, don't print out the thing with the memory address. Print out call as string and return that. And I'm going to say fallback 1. So if you try and use this as a number or in a Boolean concept, it will convert to the string by calling as string and then do what you'd expect and to convert it to a number, which is a long-winded way of saying that if I say foo new, it prints out my foo. And of course we take that back into our error class. I had an add string, talk to self, blah 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 blah, and when I throw it, now I get something useful out the end. Okay, so that handles how we can produce objects which are useful and can contain data that we can interrogate. Let's talk about the second problem, which was we don't want to be delving into our strings or parts of our object to look for something to match. We want to categorize these, to classify these, and so that we have an unchanging thing. So if someone changes the error message, we don't suddenly not be able to match it. Time for Star Trek. These are captains. Swern stole this, or I stole it from Swern. I'm not sure, but it might be independent invention. But anyway, the job of a Star Trek captain is hard. You've got Klingons coming in off the starboard bow, Romulans, Ferengi. Your ship keeps breaking. The transporter doesn't work. The warp drive explodes. The holodeck becomes sentient. You've got this guy here. Let's not even talk about this guy here. Oh, and it's not just as simple as it goes wrong. There's different ways it can go wrong. So you've got the transporter. It can combine your crew members into one. It can make you into a blob. It can transport you into a mirror universe. It can split you into a good and evil part. It can clone you. So it's a lot for a Starfleet captain to deal with. So how do they make sense of it all? They break it down, of course, into categories. So there's a starship errors, there's alien problems, and there's the crew that keeps getting killed. And they give these problems to someone else to deal with, quite frankly. That's what a Starfleet captain does. You could make it into a very big tree-like structure. And this is kind of like what we want to deal with our exceptions. We get an exception has happened somewhere in our code, and we want to, maybe we're just going to deal with the starship stuff, or just deal with the crew problems, or maybe we're going to see the exceptions and dispatch off to something that can handle a section of these. So maybe we want to handle all of the transporter stuff, or maybe we want to handle the transporter stuff and the holodeck stuff and the warp drive, in fact, all of the starship problems. So you can start producing a class hierarchy of these things. There's a generic starship exception. That is, there's a more particular transporter exception. There's a even more particular one for which we might be able to deal with situations where we've cloned a crew member. And you can start using them like this. You catch the exception, and you start looking, first of all, if it was a transporter problem, give it to O'Brien. If it's a starship problem, give it to Scotty. If the crew got killed, you've got Bones to say that they're dead. And you set Worf on all of the aliens. This is what it looks like with Tri-Tiny. With Tri-Catch, it's a bit cleaner. I just catch if the exception is of this class or this class. Now, the thing to notice here is that I'm catching things like the warp drive breaking. I'm catching things like the Klingons attacking, because Worf is catching all subclasses of aliens. So I don't have to specify every single class. This kind of thing is very common, and you'll note that it's very verbose. Let's talk about exception class. Now, we wrote our own exception-based class. That's probably not the best solution. It's important to understand how it's done, but you probably shouldn't go off and write one. What you should do is use something like exception class. That gives you access to a lot of useful methods in it. So packages, files, line numbers, you can get a stack trace out of it, and it gives you a better exception declaration syntax, which I want to have a starship exception. I want to create a transporter exception and make it a subclass of error class exceptions. So that's essentially the 101 of it, the whole problems. I did decide to add some bonus slides and some more interesting stuff at the end, but I thought I'd stop at this point and ask for questions. So, have I confused everyone? Is yes? With this one?
Is that a mistake?
Oh, yes, that is a mistake. Well spotted. Look, that's the deliberate mistake to make sure you're paying attention. Yes. Yes, that should, in fact, obviously be, if there's a problem that isn't the transporter one, Scotty should be able to deal with it. Anything else? Yes?
Do I take it from the point where you ended that you are recommending exception class?
Kinda. So, exception class is a good choice. There are many different solutions on the CPAN because it's the CPAN. Exception class is lightweight. and featureful. It can become more lightweight if you ask it to be, or less lightweight if you ask it to be, to give you the full stack trace and every time I throw an exception. It doesn't have that many dependencies. It just uses class data inheritable, which is fairly lightweight in itself. There are other solutions out there. If you're running Moose, you might want to investigate a throwable role, for example. Throwable, which is a role you can apply to your class. I didn't include it in the 101 because I wasn't sure how quickly I could talk. I don't necessarily like this syntax, so I wrote something to make it better. Yes, all the good or all the good exception names are gone. So is syntactic sugar for creating exceptions, subclassing, throwing exceptions, and checking for exception classes. In other words, it's syntactic sugar for all the things try-tiny and try-catch don't do. It uses exception class base as a base class, so it builds on top of exception class. So we wrote this. I'm not particularly a fan of repeating myself. I think that clone crew member should know what its superclass is there, because I'm just repeating myself. So this is my quicker declaration syntax, which is a little easier. Starship here is exception, which is itself is just a simple subclass of exception base class. Oh, that's the second one to make sure you're paying direct attention. Yeah. Okay, and this here, this Starship transporter is a subclass of the Starship problem. It's automatically just essentially lopping off parts of the class name. It also has this dot notation here to say that I'm going to not bother saying exception at the beginning of it. So that the idea being that your error classes are off in their own little world and not interfering with your other classes. And you can do all the other things that you do with class exception this way. You can add descriptions. Exception class has a concept of a class level description of the problem. So something that is true for is basically a human description of the problem without giving the details of what happened in a particular instance. And you can add extra fields to your objects. For example, and in this we give fields and defaults. So if you clone your crew member, we want to know what crew member it is, and we default to Riker. And throw syntax is similarly simple. Throw, this is a functional interface, so that's a function, not a method call. And it's so you simply say I call these error codes Starship warp drive, and then you just say the message you want to go with it. And to catch it, I say, is this an error? Is Starship warp drive? And this is a little less verbose. And the same, you can do the same thing with try catch, where I have where I'm using the where block. So, can you guys tell me, since you're good at spotting errors in my slides, what's wrong here? What happens if we've ejected the warp core? Right, I'll give you a clue. It's not that. It doesn't tell you that you've ejected the warp core. It says, can't locate object method new via package exception club class spaceship warp drive. Perhaps we forgot to load spaceship. Oh, bother, it's called Starship, not spaceship. Now, the trouble is, exceptions classes tend to be a bit hard to test because they happen in, well, exceptional circumstances. And you only find out that they're broken, well, at 3 a.m. in the morning on a Saturday. So the error handling doesn't work. This, on the other hand, does work. or rather doesn't work in the right way. When I attempt to compile this code, it immediately says, undeclared exception code spaceship warp drive used in through. You must declare it first. So at compile time, it works out that you've used the wrong syntax. For the more advanced people in the room, what does that mean? Well, so when you compile Perl code, there's a check phase where you check to see if the prototypes of the functions that you're using are correct. You can overload this with bcall checker. So I do so. And I grovel around in the op tree to find the constant first value you're passing in to the throw and to check that it exists at the time you're compiling your code. So you don't have to wait until it's 3 a.m. in the morning to discover that there's a problem. Which is a very long-winded way of saying it just works with magic. So, last but not least, autodie, which is me clearing up the bit that I still hate that. And introducing new exception classes isn't going to help with that. We need a way to die automatically, which we want to just write that, and that's exactly what autodie does. It automatically dies instead of causing undef. But it will only work with the functional interface. Don't try and mix it with IO handle stuff. And trust me on this, if you're using an older Perl, you probably want to install the new version off of CPAN. Otherwise, things like multiple arguments to a system call, open running YAPC as a system method will mysteriously fail in ways that you didn't anticipate. You can do the same thing with DBI. I can tell DBI, for example, I want to raise an error. You can't do the same thing with Template Toolkit, but we should patch that. So, and that is the end, which I've done in 36 minutes, which means I have about 5 minutes for any questions, and then to let you go in time to get to the next thing. So, have I confused anyone? Have I gone at too fast a speed? Have I gone too slowly? Does anybody need something else to be explained? I scared everyone to silence. Have I pointed out to the people on the internet that this is root beer, not alcohol? Sorry, Romulan layout. It's not blue. When will the slides be available? So these slides aren't particularly useful. What I'm going to do is put a slide cast up. So I'm going to say everything I just said to you again. I'll record it on top of a video of the slides, and I will endeavor to get that up by Monday morning, which is when I will have enough time to upload it correctly. Is on CPAN as of about 2 hours ago. Yes? Good question. So the way try-catch works is that it hijacks the compiler using a devel declare. Now, the way devel declare works is that it attaches to a subroutine, like try or catch, a behavior which tells Perl to stop using its own internal compiler at that point and switch to a new compiler chunk in your code, and then devel declare will call back to the main Perl compiler to execute, to do things like parsing the blocks that you pass into to try or catch. So if you're happy with it doing that, then it's fine, and I am. But it's still vastly much more immature as a technique than, say, try tiny or the inbuilt inval. And the things like that last thing is something I discovered when it bit me. So I would recommend it, but pay attention. It will save you pages and pages of code, and maybe the other thing is maybe you will save yourself that bug you get because you forgot to rethrow, or that bug you got because you put a return in the middle. So it swings and roundabouts. But both of the solutions are infinitely better than just using the eval, which just won't work on older versions of Perl. Any other questions? Yes.
So, Mark, all of these things are bad.
Yes. So the point was that these are band-aids that we're applying on top.
Yeah. So, is deflecting, is there an effort or a movement that you're aware of to make better exception handling part of a future Perl rather than something that's terribly broken in itself because, for example, try catch is the best thing.
Right.
But
So.
not using Perl?
So, right, to answer that, I refer you back to the gentleman sitting in front of us talk from earlier. To implement, the best way to implement a better try-catch block would be to change Perl, which is something that is happening, so that you can easily write more extensions into it. The try-catch system is probably something that will need significant evolving steps, not something that you're going to get right instantaneously. And it's something that you really do want as a CPAN module. Try-catch at the moment is implemented in devel declare, which is immature. Devel declare will go work on right back to 5.8, which is practically back to those dinosaur ages right now. It's the one before the one before the one before the unsupported version of Perl. So in 5.16, there are a bunch of changes to allow you to get at more of the parsing section, and more stuff is happening along those routes. That strikes me as the better route. Any change that we would put into the exception handling, we put into core Perl would obviously have to wait to a new Perl version. We might as well wait for a new Perl version where we can implement that change as a CPAN module. Because, I mean, okay, good example of try-catch is try-catch uses moose. It uses moose types. It relies on all those things. That's doing something, and at the moment moose types are our type system. But are they truly our only type system? Is that all we're going to use? Having that kind of stuff, if we were to put something like try-catch in core, it would either not be able to handle moose types or it would rely on moose. So you're then going, should we put moose in core? And so it's not as simple as this. I know, we'll just make some quick change to the Perl core and it'll be wonderful. It won't. Okay, any more questions? No? Great. Thank you for listening.